Another key aspect of Python fundamentals is for and while loops. So another way, or basically the general category for for and while loops is iteration. So for loops use the structure for item in collection of items, and then a colon. And it's used to perform a computation or operation for every element in the collection. So this collection is typically either arrays or ranges. So we will go more into this later, but it's important to remember that key structure. And while loops, on the other hand, are structured in while a condition happens, and then colon, a set of body happens. So for both of these iterations, so for item in collection of items, a set of instructions occurs, similar to functions. And so while a condition occurs, a set of instructions happens. So it's used to, for while loops, it's used to perform a computation or operation a certain number of times. I know this is kind of difficult to understand right now, but once we get into the examples, it will be a lot easier. So as we can see, we have for loops in this example. And in this example, we have an animal array where it contains cat, dog, and rat. So if we were to use a for loop, so for animal in animals, and keep in mind, actually, although we are being descriptive here, the animal, so for animal in animals, that first blank doesn't actually have to be animal. You can put X there, you can put Y there, you can put Z there. As long as in that second line, print animal, you are doing the same thing. You're doing print X, print Y, print Z. So for animal and animals, print animal. So what do you think would happen here? Maybe take a second to pause the video here and just think about what would be outputted if you run this code. If you looked at the answers on the screen and guessed that it would be cat would be printed, then dog would be printed, then rat would be printed, you are right. That is exactly what will happen. So the for loop iterates through every animal in animals. So it goes through cat, then dog, then rat, and at every iteration, it prints out that animal, or whatever variable you will eventually specify, whether that be X, Y, or Z. Another type of for loop is using ranges. So we talked about ranges earlier, and so np.arange will be an array from, I believe, 0 to 4. So it would be 0, 1, 2, 3, and 4. And that would be np.arange 5, since the end variable would be, or end number would be 5. So again, the for loop iterates through every number in np.arange, again, and after each iteration, it prints out the n. Again, in this case, we could choose n, we could choose x, we could choose y, it don't matter, as long as our print line is the same thing. So for n in np.arange 5, we print that number. So every number in np.arange 5 will be printed. So 0, 1, 2, 3, and 4 in a new line. While loops, on the other hand, are a little bit different. They do not take arrays, actually, or collections of items. In this case, we set our variable I to 1, and then we run the loop while I is less than or equal to 4, and we iterate on that I. So as long as the condition I is less than or equal to 4 is true, it will continue that body, or it will print hello and then iterate. So as we can see, we can just trace through it right now. So our first I is 1, and so when 1 is less than or equal to 4, it will print hello. So our first hello over here. And then it will add 1. So I will equal to 2. So I will equal to I plus 1. 1 plus 1 is 2, so I will equal to 2. And we go back up. 2 is less than or equal to 4. So again, it will print hello down here. And then it will iterate again. I is 2 plus 1, which means I is 3. 3 is less than or equal to 4. So again, this is true. And so it will print hello for a third time and then iterate again. So I is 3 plus 1, which is 4. 4 is less than or equal to 4. And so it will print hello again, and then it will iterate one more time, and I will be 5. So we go back up. Is 5 less than or equal to 4? No, it is false. So the loop stops. So as we saw earlier in this previous example, we used I is less than or equal to 4. In this case, however, in our different example, we start with k equals 0, so a different variable, and we also use a different, less simple condition. So in this condition, it would be k to the power of 2 doesn't equal to 16. So as long as k is not negative 4 or 4, doing the math, since k, the root of 16 is 4, so as long as k is not 4 or negative 4, it will be true. So we set variable k to be 0, and as you can see, we alter it by 1 every time. So I can just trace through this example. K is equal to 0, 0 squared is not 16, so it will add 1. K is now 1, and so 1 squared is not 16. K squared is 1, so again, it will just add 1. And it'll go up till 4, when 4 squared is not equal to 16. This is false, and so it will print K. And now that since our K is changed, it will print K, and K will be a 4. This can be seen here. So if we're going to talk a little bit about NumPy, since we have basically this entire point, I hope you come to an understanding now that NumPy as a Python library is extremely useful, especially for mathematical functions. And one other function that it offers that is really useful is np.randomChoice. So as you can see, this is the structure of np.randomChoice. And you input an array into it and the sample size, and then it will select uniformly at random with replacement from the array for a specific number of times from sample size. So based off an array, usually the array will be larger than the number of sample size. For example, we have an array of length 200, and we want a sample size of 3. So it will randomly choose 3 out of that array, 3 values out of that array randomly, and then we'll output an array of length 3, or the length of your sample size. And this can be extremely useful in statistics and when you're starting to use hypotheses, which we will talk about later, generate hypotheses, null hypotheses, and just test your hypotheses to see if something is significant and whether your data is significant as well. This is another example of this being used. As we can see, our sample size is only 2 and the array is length 7. And so it will choose 2 values at random, and in this case, it chose 6 and 5. And so let's talk a little bit about Python libraries, or other Python libraries we could use. So libraries are reusable pieces of code that make our coding more convenient. So instead of redefining variables, making new functions and classes, we can use libraries that contain all of this code already. So one of these libraries that we have been talking about this entire time is NumPy, or NumPy. So libraries typically contain code that is used for a specific purpose. So math functions, data visualizations, etc., which we will also discuss in our other modules. And so to use this code in the library, we must import it. So this is the general syntax. Import library as name. The as name is not always necessary, but it could be useful if you don't want to write out your library. For example, usually NumPy is referred to as NP, so you would import NumPy, NUMPY, as NP, and then when you refer to it, you can do np.array instead of numpy.array. Again, we will be using NumPy quite a bit since it contains all the math functions and support for arrays mathematically, and so again, as I mentioned, it would be import NumPy as NP.